Welcome to another tutorial about linear algebra. In this video, I will discuss what augmented matrix is and teach you how to solve a linear equation using the Gaussian elimination method. Let's start. An augmented matrix for a system of equation is a matrix of a number in which each row represents the constant from one equation and each column represents all the coefficients for a single variable. Example: now that you already know what is augmented matrix is, we'll proceed in solving linear equation using the Gaussian elimination method. Gaussian elimination method uses row echelon form of the augmented matrix to solve a linear equation using Gaussian elimination. First, convert the augmented matrix to REF or row echelon form. Then, solve the system corresponding to the matrix in REF using back substitution. I will give you some example to give you an idea of solving linear equation using Gaussian elimination method. Example number 1. Convert the given linear equation to augmented matrix. Now we will proceed in transforming the augmented matrix to REF. If you notice, the first non-zero entry of R1 is already 1, so we will just turn the first entry of R2 and R3 to 0. For R2, multiply R1 by -3, then add to R2, and for the R3, multiply R1 by -4, then add to R3. Next, multiply -1/3 to R2 to change -3 to +1. Turn the second entry of R3 to 0 by multiplying R2 by -5 and add to R3. Make the first non-zero entry of R3 to 1. Multiply 3 over 46 to R3. Now, the matrix is already transformed to REF. Next step is to use the back substitution for solving the linear equation. But before that, we write the augmented matrix to linear equation. By returning the augmented matrix to the linear equation, we already have the value for z. Use z to solve for other variable. Substitute z to y negative 8 over 3 z equals 6 to solve for y. We already get the values of the variable. Therefore, the solution for the linear equation is negative 43 over 23, negative 94 over 23, and negative 87 over 23. To check if the value of x, y, and z is correct, substitute them in any of the given equation. When the answer is equal, then the values are correct. Example number 2. Convert the given linear equation to augmented matrix. By multiplying 1/2 to R1, the first non-zero entry will be 1. Next, for R2, multiply negative 3 to R1, then add R2. And for R3, multiply R1 by negative 10, then add to R3. The first non-zero entry of R2 is 11. Multiply R2 by 1 over 11 to change the first non-zero entry to be 1. Now, turn the second entry of R3 to 0. Multiply negative 28 to R2 and add to R3. Before we continue, it seems like there is something wrong with an out-augmented matrix. Check the R3. All the coefficients of the variable are 0. If we will write R3 to linear equation, the equation is 0x plus 0y plus 0z equals 32 over 11. But 0 is never be equal to 32 over 11. Therefore, there is no solution for the given linear equation. And that is how to solve linear equation using Gaussian elimination method. I hope you understand how to use Gaussian elimination method in solving linear equation. Always remember to convert the given equation to augmented matrix for the easier way of transforming the given to REF, and during the process of transforming, don't forget to check your augmented matrix because there is a possibility that the given equation has no solution, just like what happened to our second example. For the next video, I will teach you how to solve linear equation using Gauss-Jordan reduction method. See ya!